I'm Mr. Tay. Today, I'm going to discuss with you another sample question regarding KSSM Physics Paper 3. So the experiment I'm going to discuss with you in this video will be one of the compulsory experiments in Form 5 syllabus Chapter 3, Section 3.2, Resistance. So the aim of the experiment I'm going to discuss with you is the experiment to study the relationship between the current and potential difference of a filament bulb. So in this experiment, you need to have the knowledge regarding the ohmic and non-ohmic conductor. So before we go to our discussion of experiment, so let me tell you about the information regarding the format of paper 3, where we want to focus today. So the genus instrument for the paper 3 will be Genus Ujian Amali. So that means you need to do experiment, get a result, and analysis. The type of question are going to ask will be all in subjective perspective. So there will be no any objective question in paper 3. And there will be only one question where the total marks will be about 15 marks for the paper 3. And the question is actually mainly testing the candidate about the process science skill. The duration for paper 3 will be about 45 minutes. I think this all information all the candidates should be already know. Okay, so and then here I want to discuss with you the type of the experiment. If let's say you have already watched my previous video, you must already know that there are actually two types of the experiment. So the first type of experiment will be known as a hypothesis experiment, where the experiment is involved 5 manipulated variable and responding variable. And normally the question will be asked you to plot the graph or the experiment where you did together with your school teacher. Regarding the hypothesis experiment, normally will be ask the students to plot the graph, which is related to the phi MV and RV you get through the experiment. So the example of the experiment which is under the type of the hypothesis experiment is actually here we have an example from chapter 3 from 5 syllabus also. So electricity. So to study the relationship between the length and the resistance of wire. So the student have to create out the experiment where change the length of the wire and we want to know the resistance of the wire with different length. In this experiment, the students are going to measure the voltage and also the current through the voltmeter and the ammeter. Then using the formula with the Ohm's law, V equal to IR and R will be V over I. This is the example of hypothesis experiment. And then we have another example here will be to determine the relationship between the mass and volume. Okay, so if I say you want to get to know more about the hypothesis experiment, so you can go through my video clip here. Then the next will be the non-hypothesis experiment. So here will be normally no involve phi MV or RV and or no request students to plot any graph. So we need to find out some of the value. So for example here, we want to see the effect of the connecting of dry cell in different arrangement and affecting the current flow in the circuit. So where this is one of the experiment, but this is not a compulsory experiment for Form 5 syllabus. And the second will be determine the critical angle of the glass block, which is one of the activity 6.3 at Form 4 syllabus. So again, you may get through more information about the non-hypothesis experiment with the video link provided here. And in today's video, I'm going to discuss with you the 15-mark question which is related to hypothesis experiment. Then the next will be regarding the type of the question. So basically, we have two types of question. The candidate will be facing the paper 3. So first will be known as the guided practical assignment. In BA, we know as Tugasan Amali berpandu. So where the procedure and diagram will be provided in the question. So it'll be more easier for candidate to answer the question. So the candidate just need to follow the procedure and diagram given by the question and conduct the experiment. So here will be the example video related to the Tugasan Amali berpandu you may be referring to. Okay, so the next will be the non-guided practical assignment. In BM, we know as Tugasan Amali berpandu. So the procedure and diagram will be not provided. For this type of question, students need to plan the procedure and normally will be draft the experiment diagram before conducting the experiment. So you may referring to my another video here where it's related to the Tugasan Amali tidak berpandu. And in this video, I'm going to discuss with you the type of question which is Tugasan Amali berpandu. So the procedure and diagram is provided in the sample question I'm going to discuss with you today. Okay, so this is a common question in the paper 3. If let's say you have already watched my previous video, so you must already know that the type of the common question are going to ask in paper 3. So the first here will be normally problem statement, then inference, hypothesis, procedure. So for the procedure, that means the students will be asked to write the procedure for the experiment. So for this type of question will be known as Tugasan Amali tidak berpandu. So where will be normally 4 marks for writing the procedure. Then the next here will be precaution of the experiment and the verbal related for the experiment. So in this video, I am going to discuss the precaution, how to write precaution for this side of the question, for this side of the experiment. So the next common question here will be tabulate your result. So this is a common question will be asked the student to tabulate. So what is the important tips you need to know and get the full mark for your tabulation? So today I'm going to teach you. Then the next number 8 will be plotting the graph. So for plotting the graph will be related for the experiment, which is hypothesis experiment. And today, this video are going to discuss with you how to get the full marks for plotting the graph. Then the next will be draw your observation. And another common question will be asked in the paper 3 will be data analysis. So the question will be asked you about the relationship between MV and RV. And then will be asked you to do some calculation related for the graph, for example, gradients and others. So operational definition can be also asked in the common question. So you may refer to my previous video, how we write the operational definition, deduction, and also the prediction. So in today's video, I'm going to teach you how to get full marks for tabulation question, together with how we plot the graph, and then the quite many questions about the data analysis in this sample question I'm going to discuss with you in this video, and then also the last prediction. Okay, so now let us discuss about the information or knowledge you already get through in this compulsory experiment together with your teacher. Okay, so this is experiment 3.1 and the procedure and the information you can get from your textbook page 100 to 102. Okay, so this is the detail for the experiment. So basically the experiment is to study the relationship between the current and potential difference of an ohmic conductor and non-ohmic conductor. So the ohmic conductor, we're using constant wire for the experiment. So basically you can see the manipulated variable here will be current, potential difference, where you may get the information in the M. So here you can see to study relationship between current and the potential difference on the ohmic conductor. So for the first, you have already has experience to do this experiment together with your school teacher. Okay, so this is the arrangement for the experiment. So I'm not going to discuss detail for this experiment. And then you will be follow all the procedure here. So here you can see there are 5 data will be collected, and then you will need to measure the voltage via the voltmeter here. Okay, so this is the end of the experiment. Just like I discussed already. So related to the first experiment will be ohmic conductor by using the constant wire. Okay, so you have to collect the data where the NV will be current by the reading of ammeter. Then the RV here will be potential difference, which is reading of the voltmeter for the first experiment. Okay, so the graph we get will be, you can see here, I against V, or normally we brought as V against I lah. Okay, so we may get a straight line passing through the origin. Okay, so the second experiment will be on the non-ohmic conductor. So here in the textbook, we're using the filament bugs. Okay, so the variable related for the experiment will be manipulated variable will be current, potential difference will be voltmeter, and the constant variable will be filament length. So as we're using the same bug for the experiment, so the length will be always the constant, because we know that if the length of the filament changes, so there will be changes the resistance for the circuit here. Okay, so again, you can see in this experiment, so you just replace the constant wire to filament bug, and then again you need to correct the data, and the data here will be again RV, NV here will be current, and RV here will be voltage. Okay, so the graph expected, so the graph you get through this compulsory experiment supposed to be almost like this. Okay, so it's a curved line passing through the origin. The experiment 3.1 here is actually mainly want to compare the shape of the graph and the gradient of the graph for these two type of the conductor, V against I. Okay, so this is a comparison of the graph V against I. Here, next one I. V against I for an ohmic conductor and non-ohmic conductor. Okay, so for graph of V against I for ohmic conductor, we expected a straight line passing through the origin, so it'll be like this. So the M where represent as the gradients of the graph is actually represent as the resistance. So that means you can get the resistance from the graph using V over I. So where you will see this is a constant gradients. So that means that the resistance will be constant for ohmic conductor. So where we can conclude that this is where we can conclude that for ohmic conductor, there will be obey Ohm's law, where the gradients will be constant or the resistance is constant. Okay, so the relationship between V and I for ohmic conductor will be directly proportional. So you can see this is a straight line passing through the origin here. Okay, so while for the non-ohmic conductor, so you can see the curve, a curve pass through the origin. Okay, so it will be this, a curve passing through the origin. Okay, so the gradients here is actually not constant. Okay, you can see it's not a straight line. Okay, so how we can get the gradients? So you can get from each point of the curved line here. Okay, so this is the initial resistance. So where the resistance here is actually lower. Okay, you can measure the, you can calculate the gradients. Okay, you can calculate the gradients of the point here, and you can see the gradients at the point where the I increases, the resistance become higher. So the conclusion here, the gradient is not constant, so the non-ohmic conductor will be not obey Ohm's law. Okay, so the relationship between V and I through the graph will be V increases with I. Okay, so now the next comparison will be the rate of the increase of the voltage. So from the graph, you can see the gradient is constant. So here will be constant. Then for the non-ohmic conductor will be increases. Okay, you can see the gradients are shown by these two triangles. Okay, so the I higher will be showing higher resistance. So the resistance of the ohmic conductor will be constant, while for the non-ohmic conductor, the resistance will be increases when the current increases. Okay, so the parts I want to highlight in this experiment will be the information regarding the non-ohmic conductor. So in the experiment where is stated in the textbook, experiment 3.1, so the bar is used to show the characteristic of the non-ohmic conductor. So the bar is actually uses the constant coin to light up. So the constant coin is actually not a non-ohmic conductor, it's actually the ohmic conductor. But when the current flow through the coin, so that means the current flow through the tungsten coin, so the temperature increases and causes the bulb light up. Okay, so during the current flow through, the temperature will be increases. So causes the resistance will be increases. So you can see gradients increases with the current, indicate that resistance of the filament increases with temperature. So this one will be shown by the graph. So the current increases, the hotter the filament. So the greater the vibration of the atom in filament. So when the vibration bigger, so the electron not able to flow through. So the resistance will be increases. So that is why the tungsten coin will be behave as the non-ohmic conductor when the current increases. So under this condition, where temperature cannot be keep constant, so the tungsten coin in the bulb will be exhibit as a non-ohmic characteristic. So that means that if I say with the low temperature, so the tungsten coin will be expected showing the ohmic conductor character, where will be obey the Ohm's law. But when the temperature increases and causes the tungsten coin behave as the non-ohmic conductor. So the conclusion, so we can observe the gradients which is represent the resistance to indicate that so the conductor is obey the Ohm's law or not obey the Ohm's law. So when the conductor obey the Ohm's law, we know as the ohmic conductor. When the conductor will not obey the Ohm's law, so will be known as the non-ohmic conductor. So you can see the statement. So ohmic conductor obey the Ohm's law, while non-ohmic conductor not obey the Ohm's law. Okay, so this is the candidate checklist. So during the paper 3 examination, so you will get the checklist like this. Okay, so this will be the instruction. So let's go through the instruction. So you are not allowed to work with the apparatus in first 5 minutes. The period is used to check the apparatus list, read the question and plan the experiment which is carried out. Mark in the box provided to check the material. So checklist for the apparatus and material provided will be this. Okay, so that means here, the first 5 minutes will be used to check the apparatus and plan your experiment. So just now we mentioned that there will be 45 minutes for examination of paper 3. So here you need to minus 5 minutes, right? For check the apparatus, read the question, and plan the experiment. So you left another 40 minutes where you need to conduct the experiment to get the data and complete the question in paper 3. Okay, so this 5 minutes is actually quite long for you to do the planning. Okay, so you need to read the question and then plan the experiment. But for this question, so there will be the Tugasan Amali berpandu. So the procedure is provided, so it will be more easier for the candidate to answer. Okay, so here, if I say you check already, all the apparatus involved, where will be the filament bulb with holder, battery holder. Then the battery here provided is 2, ammeter 1, voltmeter 1, the connecting wire is 8, 1 rheostat and 1 switch. If let's say you check all the apparatus, the quantity is correct and also functioning, so you may take your checklist and start to plan your experiment. Okay, so you can straight away go to read your question and get to know what are going to do for your experiment within these 5 minutes. So you are required to study the relationship between the current and the potential difference of the filament bulb. So here is very clear that so the current and the potential difference are going to measure. Okay, so one will be RV, one will be MV here. So the MV will be current, RV will be potential difference. So you can know through the procedure here. Okay, so you can see, carry out the experiment by using the step below. So set up the apparatus as shown in the diagram. So diagram here, very clear already. So how we connecting all the components here. So firstly, close the switch and adjust the rheostat until the reading of the ammeter, which is I equal to 0.06 ampere, and you need to record your voltmeter. So repeat step 2 with others value of the I. Okay, so when the procedure is provided, so this type of the question we know as Tugasan Amali berpandu. Okay, so the students just need to follow the procedure provided and carry out the experiment. And then from the question just now we read, okay, so we may know that there will be about 5 MV and 5 RV are going to measure. So we expected the question will be need to plot the graph. So you can go through the question. So you may know that this type of the experiment will be the hypothesis experiment. So the next, you need to know all the variables involved in the experiment so that you know what you need to record. Okay, as per explanation just now, we know already. The first step, you need to identify MV and RV. And the MV here will be current. So you may get your reading from the ammeter. Then the RV here will be the potential difference. And the reading you want to get will be the voltmeter reading here. Okay, so after you read the procedure and the diagram given, you need to relate the MV and RV needed for data collection. So here actually very easy, all is given already. You just follow. Okay, so our first MV will be 0.06 ampere. So you need to follow, cannot use your own data. Okay, then you need to correct your RV reading through the voltmeter. Okay, so this will be another 4 MV and the respective RV will be going to measure and correct also lah. Okay, so at the same time, just now we mentioned already, the CV for the experiment is actually the length of the filament. So since we're using the same bulb, so the length of the filament will be always constant. So if I say the question asking you the constant variable, so this will be the answer. Okay, so the step 3, draft a table for MV and RV. Fill up the table during experiment. Okay, so that means here you can draft a table. I for current, V for volt. Okay, so the first reading 0.06, okay, 0.08, and so on. So within these 5 minutes, you know what to do later on. Okay, so after the 5 minutes, you may straight away start your experiment. And this will be just follow the procedure. Okay, so now I want to show you how I conducting this experiment, which is related to study the relationship between the current and potential difference of a filament bulb.
Hi everyone, I am Mr. Day. In today's video, I'm going to discuss with you one of the compulsory experiments in Form 5 syllabus, Chapter 5, Electricity, subtopic of 3.2, Experiment 3.1. So it's actually to study the relationship between the current and the voltage on a non-ohmic conductor. So the apparatus we are going to use for this experiment will be rheostat, battery holder, voltmeter, ammeter, but which will be used as a non-ohmic conductor, switch, and also connecting wire together with the drive cells. Before we start our experiment, you should know what is the MV and RV we are going to measure in this experiment, and what is the CV for this experiment. The MV for this experiment will be to measure the current flow in the circuit. So there will be 5 MV are going to measure in this experiment. So there will be 0.06, 0.08, 0.10, 0.12 and 0.14 as stated in the procedure. And another 5 RV will be going to measure will be the voltage flowing in the circuits. If let's say the MV reading is not stated in the procedure, where the question is a type of Amali tidak berpandu, so that you need to find out the maximum and minimum value able to conducted for your ammeter. So that you need to use the maximum value minus the minimum value divide 5 and get the 5 manipulated variable to get your RV. So however, for this experiment, the procedure is provided. So now let us arrange and connecting the apparatus according to the diagram. So basically, the series circuit will be involving the apparatus besides the voltmeter. So the ammeter will be connected in series for others electrical components, while the voltmeter will be arranged parallelly to the circuits. Now let me show you how to arrange the circuit according to the diagram. Our connection can be started with the battery holder. So you may see there is one button at the bottom of the battery holder, which is the negative terminal, and there are 4 buttons at the top, which is represent the positive terminal. And the 2 batteries are going to use in this experiment. So first, battery must be inserted with the space together with the negative terminal. Then next will be second button. So your negative terminal will be connected at the bottom, and the positive terminal for the connecting wire will be at the second right of the battery holder here. So now let us arrange the apparatus according to diagram. So firstly, your arrangement will be arranged series without voltmeter. So connect the positive terminal of the battery at the second button at the top. Then another side, connect to the one of the terminal of the switch. Then next, connect the coaxial clip to the another side of the switch, and here will be another side of the connecting wire will be connecting to the positive terminal, which is the red button here. So here we have 1 ampere and 5 ampere. You should connect your coaxial clip to the lower reading of ampere before using the 5 ampere here. So connect to the lower reading of the ammeter, and when you're connecting your connecting wire to the 1 ampere, your reading still should be to the bottom where the maximum value here will be 1. If you change your connecting wire to 5 ampere, your reading should be at the top where the maximum value will be 5. Okay, however, we should start with the lower value of the emitter here, so it will be 1 ampere button. So next, connect the connecting wire to the negative terminal of the emitter, which is the red button here. And then connect to the one side of the bulb. And then now we want to connect the connecting wire to another side of the bulb holder here.
Now, I would like to show you how to connect the rheostat in the correct way. To understand this connection, you have to understand the basic components of the rheostat. They are consist of 3 terminals in the rheostat. The lower left part of the button is terminal A, and the lower right part of the button is called as terminal B, and the third terminal will be at the top left side, and that is the terminal C. And this is the sliding contact, which will be controlling the length of point wire connection to the circuit. A rheostat is actually a variable resistance, which is no polar. Either terminal can be connected to the either side of the circuit. So that means that the 3 terminals in the rheostat is not considered as any terminal positive or negative. In theoretical, we know that the longer the coil wire, the higher the resistance will be, and the lower the current will be produced in the circuit. Basically, there are 2 ways to connect the rheostat. The first method will be connecting the rheostat with the terminal B and terminal C. So the terminal C will be at the top left side of the button, and another connection will be at the terminal B, which is at the bottom right side. Now, I want to show you how we connecting the rheostat with the method 1. Basically, the rheostat consists of a coil wire. As mentioned that the longer the wire, the higher the resistance will be. And now, you can see that we started our connection with the first connecting with the terminal C at the top left side, and then connect to the bottom right side, which is the terminal B. You can see that the current at this position will flowing from here to here, showing the shorter distance of the coil wire. Therefore, the current will be showing higher value, because in the shorter distance of the coil wire, the resistance will be lower and the current flowing will be higher. Now, when we sliding the sliding contact to another side, you may see that the pointer of the emitter is reduced, showing that the current flowing through the circuit is reduced already, because the current flowing from here to here and moving at a longer distance of coil wire to another side. Therefore, the longer the distance moving, the higher the resistance, and the lower the current will be flowing through the circuit here. Next, I would like to show you the simulation of connection of the rheostat with the second method, where the connecting is between terminal C and terminal A. Here, you can see that the Kodak clip is already connecting to the terminal C, where the position is at the top left side. And now, we are connecting the another connection to the terminal A. And now, we are showing that the diffraction of the current at this position showing the highest reading. This is because the current is flowing from here to here and here with the shorter distance, and the resistance will be lower at this position, so that the current is higher. And now, when the sliding contact is moving to another side, you can see that the emitter reading is reduced due to the resistance is become higher, because the current from here will be flowing to here and moving with the longer distance at the point of wire and to this position and flow up, so that the longer distance of the point of wire producing the higher resistance and the current will be reduced. Last, I would like to show you the wrong method of the connection of the rheostat, which is at the terminal A and terminal B, and you should avoid the connecting of the rheostat with these two terminals. Here you can see that the rheostat is connecting at the terminal A and terminal B, which is at the lower part at the rheostat, and you can see the current is showing at the 0.1 ampere. When we are moving the sliding contact to another side, the reading of the ammeter is remain the same. This is because at these two positions, the length of the point of wire is remain the same, even removing the sliding contact with these two positions. And you can observe that the current is always the same, whatever we are trying to moving our sliding contact to left and right. This is because the resistance is remain the same with the same length of the point wire, so that you should avoid the connection of the rheostat at terminal A and terminal B. That's all for the simulation regarding the connection of rheostat.
And here you may see the rheostat. Here we have 3 buttons, 1 button at the top and 2 buttons at the bottom side here. Okay, so one of the connecting wire should be connected to the top, another one will be connect to the one of the button at the bottom. You should not connecting your 2 connecting wire to the bottom button here, because there will be no any length changes in the rheostat, so the variable resistance value will be not able to get. So in simply say, one of the chloride clip or connecting wire will be connect to the top, another one will be to the bottom. Okay, so you can choose to the left or to the right. So I connect the chloride clip to the top first. So now I am going to connect to the one of the button at the bottom. Okay, so here we'll be connecting to the negative terminal. So as the ammeter at this direction is connecting to negative terminal, so will be at the bottom button or the battery holder. Okay, so your series circuit is already successful connection. So you may test the circuit by close the switch. So you can see the pointer of the ammeter is deflected, showing that the connection is successfully. Now let us continue to the connection of the voltmeter, which is parallel to the circuit. Now you can see the left side of the dot holder is connected to the negative of the terminal negative of battery. So we need to connect the left side of the dot holder to the negative terminal of the voltmeter here, which is the red button of the voltmeter. And then the positive side will be to another side of the dot holder, to the positive terminal of the voltmeter, which is in red color button. So close your switch. You may adjust in your rheostat. So you can see the voltmeter is deflected, so showing that the connection is successfully. And you can see the bulb is also light up. So now we can start measure from our first MV reading, which is 0.06, by adjusting the rheostat to left and right.
This is a close-up view for taking a reading on a voltmeter. You can see an image is formed on the metal strips. Therefore, the Planck's error is occur. Your eyes should be at this position so that there is no any image formed on the metal strips. At this position again, you can see the image is formed on the metal strips, so that you must ensure that your eyes is exactly in the front of the mirror when taking a reading on a voltmeter, so that no image is formed on the mirror strips.
So here the reading of the ammeter is 0.06. The voltmeter reading here will be 0.10. Then we go to our second MV reading, which is 0.08. So 0.08 reading for ammeter and 0.15 volt for the voltmeter reading. So our third MV reading will be 0.10. Okay, so this is 0.10 and our voltmeter reading here will be 0.20 volt. So our fourth MV reading 0.12 ampere and given us 0.30 volt. So now we are measuring the last MV reading, which is 0.14 ampere, and the voltmeter reading is showing 0.60 volt. So now we have successfully to get 5 MV and RV reading, and we need to plot the graph V against I according to the question, and also the end of the experiment, where we want to see the relationship between V and I for the non-ohmic conductor, and we expected a curved line passing through the origin, where they will not obey the Ohm's law. So let us plot the graph together and discuss why non-ohmic conductor do not obey Ohm's law.
Welcome back. So after you completing your experiment, now you must straight away come and answer your question. You may not spend too much time on your experiment because the marker will be only see and read your question, and he or she is actually to know what you are doing, during the experiment. So they will be check the answer from the question. Okay, so the first question here is tabulate your data in the space provided, and here is 3 marks. So how we get the full marks for tabulation? Okay, so here, first, your table must be include the quantity physics. So here will be the current and voltage. Then second will be the unit for the quantity physics. So it will be ampere for current and voltage for potential difference. Okay, and then here the next will be primary reading with decimal places based on the sensitivity of apparatus and consistency. Okay, so what is this? So the primary reading will be referring to the data you straight away measure through the apparatus. For example, here will be the ammeter and the voltmeter. Okay, so the reading must be depends on the sensitivity. So that means the decimal place in your reading given in table must be follow the smallest division in the apparatus. Okay, then the next will be the secondary reading with consistent decimal places. Secondary reading will be the reading where calculate from your primary reading. For example, we want to get resistance. So resistance we get from formula V over I. Okay, so the reading you get from the resistance and the calculation you get from the resistance we know as a secondary reading. Before we go to the detail of tabulation, so let me show you how identify the sensitivity of the apparatus. So here I want to show you how we get the reading of the voltmeter. Where is the RV for our experiment. Okay, so you can see for this case, so initially we need to know the smallest division for our apparatus. So you can see here from 0 to 1, there is about 10 segments. So 1 divide 10, so we get 1 segment is about 0.1 volt, right? So that means the reading here is very clear. So with the 0.8. Okay, so here the smallest division for voltmeter, for my voltmeter here will be 1 divide 10 equal to 0.1 volt. So your apparatus sensitivity might be different with me. So you just refer to the same method. You need to identify the one segment for your ammeter. So just like I mentioned, the reading here will be 0.8. So the answer for your reading here will be 1 decimal place. So the consistency here means that your all reading must be with 1 decimal places for different MV. So the case 2 here, you can see the voltmeter. Okay, so you can see the voltmeter reading, the pointer is actually at the middle between the first segment and second segment. Okay, so let's say we follow the case where the smallest division is 0.1. So you can choose your reading as 0.1 or 0.2. So both is accepted. Okay, so you see the pointer is between the division, between the segment just like I explained to you. Okay, so the first you can use the smallest division as 0.1 volt, where I teach you just now. 1 divide 10 segment, we get 0.1 volt. Okay, so you can get your reading at 0.1 if you let's say you get the, if let's say you want to give the reading below the pointer. If let's say you choose to get below the pointer, make sure you get others reading where when the pointer showing at the middle of the between two division, you also choose the below pointer. So let's say you choose above the pointer where it will be 0.2 volt here, so they will be always choosing the above the pointer when others reading also showing at the middle or between the division. Okay, but here you can actually using smallest division where 0.1 volt will be just now the smallest division. So you divide by 2. So you get 0.05. So that means here, when we take our smallest division at 0.05, so this reading can be read as 0.15. Okay, so 0.15 volt. So here when you get your small division as 2 decimal places here, 0.5 volt. So your reading must be consistency with 2 decimal places. Okay, so for 2 decimal places, we only can accept 5 and 0. So that means you cannot choose 0.13. Let's say you think that the pointer is more closer to the bottom segment, so you give 0.13, and you think that the pointer is more close to the 0.2, you choose 0.18. So this will be wrong. So we just can accept 0.05 for the second decimal places here. So make sure if you choose 2 decimal places, so the second decimal places will be appear as 0 or 5. Okay, so here we go to our discussion how we get our full mark for tabulation. Okay, so firstly, the question asking us to tabulate the data. So from the procedure, there are only 2 MV and RV we are measured. So here will be, we need to give the reading of current which is reading of ammeter, and the voltage from the voltmeter. Firstly, you must give the symbol or the parameter for the MV, which is I. V will be for voltage. Then second, you need to give correct unit. Ampere for current and volt for voltage. Then the next, as per mentioned just now, you need to give primary reading, where follow the sensitivity of the apparatus and consistency. And then together with the RV reading also. So this is a tick number 4 and number 3. So for the first reading of the ammeter will be 0.06, where we'll be following the reading started at the procedure. So you can see, okay, so you can see the reading here for my ammeter will be 0.06. Okay, so how we get 0.06, as I mentioned just now. So here you can see 0 to 0.2 here. So together with 10 segment. So 0.2 divide 10, we get one segment will be 0.02. So the third segment here will be represented as the 0.06. And why I read the skill below, you actually already know from my stimulation. So because the terminal positive I connecting is to the lower ampere, so I will read the skill at the bottom. Okay, then the reading for the voltmeter, you need to again follow the sensitivity. Okay, so from here, this is the first reading I get, where you can see it's very straightforward. So the sensitivity, one segment refer to 0.1, or you can choose 2 decimal places, 0.10. So I choose 2 decimal places. Why? Later on I show you why I choose 2 decimal places. Okay, so here you can see choose 2 decimal places as the voltage changes is very small. Okay, so when I go through the experiment, I realized that the voltmeter reading increases very slowly at the beginning. Okay, so let me show you my second reading. So when the ammeter showing 0.08, my voltmeter reading, you can see the pointer is at the middle. Okay, so as I teach you just now, let's say we're using the smallest division as 0.1. So I can choose 0.1 or 0.2 for my ammeter reading. Okay, so you can see, if I say I choose 0.1, so the reading will be set as the first RV reading already. So to choose 1 or 2 decimal places, you actually need to see your reading. So this is impossible. I want to get the second RV reading, which is same with my first reading, and go through the theory. So the graph we expected, there will be increases, whether it's for ohmic or non-ohmic, right? Okay, just for ohmic, so the graph will be a straight line passing through the origin, but for the non-ohmic will be also showing a curved line, which is increases. So that means that the more logical we choose for the 2 decimal places, so that they is showing the different or showing the increases for your second and RV reading here. So here I choose the smallest division as 0.05. So the reading here will be 0.15. So again, for the third reading, so you can see the reading here is 0.20 for my RV. If I take the second reading, just now I choose 0.1, which will be same as the first RV. If I say I choose 0.2, that will be same as the third RV reading already. So this is why we can actually choose the 2 decimal places for our smallest division, where is more visible for our data correction here. So you can see here, first 3 readings showing increases of the voltage. So that means this is a correct way we continue our experiment. Okay, so the next will be, you can see the third reading is no any problem, where we get the reading is 0.3. Then the last reading here for 0.14 ammeter reading here. So my RV here will be, I get 0.6. So here all the voltage reading is increases. So it's actually what we expected. Okay, so here the reading for our MV here or RV here, both must be consistent. So consistent, that means the decimal places must be the same. So here showing 2 decimal places. This one should be no problem because the readings provided from the procedure. We just follow the reading given by the procedure. Okay, so for the RV, so when you choose the smallest division with 0.05, which is 2 decimal places, when you write your reading for the voltage, you also need to give 2 decimal places. Let's say you write as 0.1, 0.2, 0.3, and 0.5. And there is only second RV here, 0.15. So that means the reading is considered as not consistent. So the mark will be deducted. Okay, so for tabulation, for this tabulation, the secondary reading is not involved because the question not ask you to calculate any reading. So let's say the question will ask you to give the reading of R resistance, so they will be stated in the question. So for this question, it's very simple. The question just asks you to tabulate your data. So the data here will be only MV and RV, which is current and voltage only. So if I say the question involve other secondary reading, which is need to calculate, so will be stated in the question. So if I say the 4 tick here, 1, 2, 3, and 4, you manage to get all correct, so you will get full marks. Let's say you get 2 or 3 tick only, maybe for example your sensitivity or your consistent is not meet, so one of the mark will be deducted. So you will get 2 marks and others lah. Okay, then the next here will be second question, which is 3 marks regarding the plotting the graph. Okay, so how we can get full marks? So here will be also, we have 7 tick you need to meet. Okay, so analyze the data obtained in A by plotting the graph of V against I in the graph paper provided. Okay, so it'll be like this. So the data showing here is I actually just copy and paste to here. So this is the data we measure through our experiment. So now we want to plot the graph. Okay, so the first tick will be you need to give the quantity physics for each axis. So V and I here lah. So this is the first, you need to give the symbol V and I for each axis here. So you get first tick. So total we have 7 tick you need to fulfill. Then the second tick will be you need to give the unit for both y-axis and x-axis here. So since the question asks you to plot V against I, V will be y-axis lah. So the symbol will be unit will be V also. Then for I, the unit will be ampere. Okay, so this will be the second tick. Okay, then the third tick here will be the uniform scale. Okay, so you can see the scale I already give here. So the scale is not going to give you straight away from the question. So you need to give the uniform scale. So what is the uniform scale? Okay, so here you can see the first statement. So you need to give the correct scale where firstly you need to identify the minimum and maximum value for your question. So you can see your minimum current here will be 0.06. Your maximum will be 0.14. Then the voltage will be 0.10 and 0.60. So your scale here must be including the minimum and maximum value. So you can see my scale here, 0.06. Here, 0.14 is here. Then the voltmeter reading will be 0.1 to 0.6. So you can see all my reading is including in the scale. Okay, so here some of the students will have a common mistake. So started the value 0.06 first, then 0.08, then 0.10. So that means here not considered as the uniform scale because the first 10 box here represent 0.06. Others will be represent 0.02. So please avoid this kind of mistake. Okay, so then the next, so after we discuss minimum and maximum value for the axis, so now we go to the reading here must be start with 0. As I mentioned just now, so here 0, if I say here you put 0.06, so the scale will be not uniform already. And then the scale normally will be 10 box or 1 unit here. We want to have the multiple of 1, 2, 5, and 10. We do want 1 unit here started with 3, 6, 9, 12. Okay, so this type of scale is not considered as a uniform scale. Okay, because the 1 box here will be 0.03. So we not consider this type of the multiple 3, 4, 6, 7, 9. This type of scale will be considered as a not uniform scale. You should choose 2, 1, 5, and 10. Okay, so here you can see my smallest division. Y-axis here will be 0.1 divide 10. You get 1 small box here is equal to 0.01. So it will be multiple 1. Then the y-axis here will be 0.02 divide 10. So here got 10 box. So the 1 small box represents 0.002. So it will be multiple 2. So here we meet our uniform scale. So this will be the third tick for plotting the graph. Okay, so the next will be size of the graph. Okay, so your size of the graph must be greater than 4 times 5. So that means your reading here plot in the graph must be at least 4 unit here. 1, 2, 3, 4. And 5 unit here. 1, 2, 3, 4, 5. So that means this is a half of the graph. So your size of the graph must be at least half page of the graph paper. Okay, so this tick should be not hard to meet. Okay, then another 2 tick here will be plot all points correctly. So you see we have 5 points. So you must correctly plot 5 points correctly. So you get another 2 tick here. So the first 0.06 and 0.10. Okay, so this experiment data is quite easy to plot because it's straightforward from 0.6. So 0.6 and 0.1 will be here. So our first point will be here. Okay, so plot 5 and 6 tick will be plot point correctly. So it will be here. Okay, then our second reading will be 0.08, 0.15. So 0.08 will be here. 0.15 will be here. Right? So because this is 0.1, so half will be 0.05. 0.05. So that means here will be 0.15. Okay, so this will be the tick. And also another 3 tick here. So you can see, if I say you manage to plot all the graph, you manage to plot all the point here correctly, so you will straight away get 2 ticks. So now you get already how many ticks? 1, 2, 3, 4, 5, 6. So we still have another tick. So the last tick here will be you need to draw a baseline. So what is the baseline here? Okay, so the baseline, you need to fulfill 2 requirements here. Numbers of points different above and below the line cannot be more than 1. So what means like this? So for example, this is a graph. So you plot a straight line here already. So you see your graph will be like this. 2 is on the line, and then another 3 is out of the line. So you can see above the line we have 2. Below the line we have 1. So 2 minus 1, so we get 1. So that means this one still fulfill the first requirement for the baseline. Then the second requirement will be the distance between the line to the point. So the distance here cannot be more than 0.5 cm. If I say more than 0.5 cm, so this will be considered not a baseline. So for example, here although you get 4 lines on the line. So one line is very far away. So although this one is above 1 point, bottom 0, 1 minus 0, 1. So fulfill the first requirement. But you can see the distance is very far. So it's more than 0.5. So this one is also not considered as a baseline. Okay, so you can do the experiment again or adjust, because nobody will know how you get the data. But you must know what the data you need to actually get. Okay, so if let's say you fulfill these two requirements, so where the different point above and bottom of the line less than 1, and the distance of the point to the line less than 0.5, so you will get the tick number 7. So like this is our graph. Okay, so this is my graph. Okay, because I'm using the computer to draw, so actually you need to draw more smoothly. Okay, actually it will be like this better. Okay, so now assume that my graph here is the best line. You can see all the point here, first, second, and the third, and the fourth point is on the line. So 1 point is slightly above the line, and 1 point is slightly down from the line. So here is also considered a best line. So make sure you draw more smoothly by your pencil, okay, during the paper 3 examination. Okay, so avoid using pen for plotting the graph, using pencil. Okay, so here will be considered as a curve, but you can see at the beginning is actually a straight line passing through the origin, right? So here we can see that the initial reading showing that with low current, so the buck is showing or exhibit as a ohmic conductor, right? Okay, so you can look at the next question here. You can see, so here we'll be going to the analyzed data already. So Ohm's law stated that the potential difference V across a conductor. So here the conductor can be ohmic, can be non-ohmic, but here when directly proportional to current, so this will be the ohmic conductor. Okay, so based on the statement above, determine the range of the current that obey the Ohm's law. State and show on the graph how you determine the range of the current. Okay, so this is the graph just now I drew together with you. Okay, so you can see from this graph, so actually you need to draw freehand for this, and you will see the reading before 0.10 showing the line is actually a straight line. Okay, a straight line passing through origin. So you can see here the question asks you to give the range where the current obey the Ohm's law. So that means the beginning with the lower current, so the temperature where is lower, so the tungsten coin, which is the material used in the filament bulbs, will be showing obey the Ohm's law. Okay, so here the range will be 0 to 0.10 because the question asks you to give the range. Okay, and then the second, show on the graph how you determine the range. Here you need to give 2 marks. So the range will be 1 mark, showing on the graph the position where showing obey the Ohm's law. You need to draw the line. Will be this line actually on the graph. Okay, so now I show you the answer together. Okay, so the tips here, the range of the current that obey Ohm's law. Okay, just now I explained to you already. From our graph here will be 0 to 0.1. Okay, do not forget to show your graph the location of the position. Just now I also highlight already. This is statement number 2. Okay, so first you need to give a line where showing straight line, which is before 0.10 ampere here. So this will be the first mark. Then give the range where obey the Ohm's law, where I equal to 1 to I equal to 0.10 ampere here. please remember to give your unit, okay, for the answer. Okay, so this will be 2 marks. Okay, then the next will be analyzing question also. So the gradients or the gradients of the graph represent the resistance. Okay, so this one, the question straight away given you. The gradients represent as a resistance. So the question can ask you also, what is the physical quantity represent the gradient? So it will be resistance because of the Ohm's law. Okay, V equal to IR. So V over I will be R. So we plotting V against I. So the gradients will be R. Okay, so state how resistance varies with the current. Okay, so again, you need to see your graph again. So you can see your gradients is actually keep increasing, right? If the current increasing, so you want to give the relationship between resistance and the current. So from the graph, you can see that. So when the current increases, the resistance increases. Okay, so you can see the gradients on the line become stepper. So stepper, that means the gradient increases now. R, this one is higher compared to the R at the beginning. So which is lower with lower temperature. Okay, so that means that when current increases, so the resistance will be increases. So the answer here will be when current increases, so the resistance increases. So this is the relationship between current and the resistance. Okay, then we go to question number E. Okay, so this is considered as a prediction question. Okay, so the question given you a formula and asks you to predict the power here. Okay, so let's go through the question. So the electric power P used by the bulb is given by the formula P equal to IR, P equal to I squared M, where the M represent as the gradients. Okay, so from here you can see when P equal to gradient, so that means the formula is actually you also learn already, where you learn at section 3.4, chapter electricity. Okay, so this is the question actually try to ask. Okay, so this is again our graph. Okay, so here, calculate the gradients M when I equal to 0.12 ampere. Show on your graph how you determine the M. So now I want to ask you to calculate the M. So 0.12 is here. Will be here. So you can see this is a curved line. Okay, so we want to get the gradients of the point. So you need to draw a triangle here. Okay, so you have to draw a triangle like this. Okay. Then you get your Y, which is here 0.4. And here will be, you can use your ruler now. Here will be 0.13. So you need to minus. And then your X, here will be 0.12, 0.14. And here will be 0.102. As we know already, the small segment here represents 0.002. Or just like I discussed with you at the graph. So your substitution will be like this. 0.49 minus 0.13 will be here. Divide 0.14 minus 0.102. So this is a gradient, mathematics. So you will get your value at 0.47 volt per ampere. So the unit will be here. Okay, make sure you give minimum 2 decimal places and correct unit. So first mark will be triangle at the graph. Second will be substitution. Third will be answer with correct answer with correct unit together. Then the next here also the prediction. Okay, so ask you to calculate or predict the P value when the current flow is 0.12. So the formula is given by the question here already. So P equal to I square M. So the M is R. So you will get the power will be 0.14 watts. So again, here must give minimum 2 decimal places for your answer with the correct unit. Okay, then we go to our last question. So where will be the precaution I'm going to discuss with you? Okay, so step 1 precaution for the experiment. So how we write the correct precaution? So here will be 1 mark. So you need to give the method together with the reason. If I say you give the reason, if I say you give the method without reason, so the mark will be not given. So the first sample answer here will be all connecting wire are tightened so that current can flow well. So here, all connecting wire tightened will be method. So current can flow well, so will be the reason. Okay, then the second reference answer here for you will be turn off the switch every time a reading is taken. So this will be the method, so that the connecting wire does not heat up quickly. So this will be reason. So because the temperature increases will cause us resistance increases. Okay, so the bracket is information for you. You just need to write the sentence here, where including the method and reason for your answer. So these two sample answer is suitable for all the experiment related to electricity. Okay, so last here got another sample answer for your reference. So position of the eyes must be perpendicular to the reading or skew of the ammeter. Here also together with voltmeter. So to avoid or reduce the apparent error. So you can see here will be the method and here will be the reason. So that's all for my sharing in this video. If you think that this video is helpful, please share to your friend and subscribe my channel so that you do not miss out my others video clip. That's all for my sharing today. Thank you for your attention. Bye bye and good luck to you.